Hey, it's Katie with TutorPUG, and I'm going to show you how to do some fairly simple partial derivatives. This is just a section on how to find or how to calculate the partial derivatives, not to actually interpret them. I'll do that in a separate video. So if you look up here, I have put a multivariable function. The multivariable function is called a, depending on b and c. And it behaves 4b squared c minus 2 ln c plus 3c cubed plus 6. And our job is to find the first partial derivatives. That's all we're going to do to begin with. So since I've got two input variables, I'm going to have two first partial derivatives, a sub b and a sub c, or a with respect to b and a with respect to c. So what I have to do if I'm deriving with respect to b is, first of all, I'm only concerned with terms that have a b in them. So I'm interested in this first term because it contains a b, so it will get derived, but it's going to be derived with respect to b. One way to approach these until you become comfortable with them is, if the term contains the variable you're deriving with respect to, then write down all the other parts of that term that aren't that variable to start with. So this, I'm deriving with respect to b, it has a b. I'm going to write down all the other parts, the 4 and the c, and now I'm just going to focus on that b squared and multiply by the derivative of b squared, which is 2b. This next term has no b in it, so it is acting like a constant. The whole thing could be thought of as the number 3 or the number 7. I'm deriving with respect to b, which means everything else, numbers and letters, are treated as constants. And the derivative of a constant is 0, it goes away. So I just skip over this, or I can put a 0 or just ignore it. There's no b, no play, go away. Next guy, no b, no play, no, go away. And the last one, that's a 6, the derivative of a constant is 0. So the derivative, the partial derivative of this whole thing, just with respect to b, is this amount, which I could simplify to 8bc if I wanted to. Now let's come down here and find the first partial with respect to c. So again, I'm going to go through and I'm only going to mess with the terms that have a c in them, because that's who's playing the part of the variable right now. So this guy has a c, and if I want to, I can write down all the other portions of that term that aren't c. And now all I have to focus my brain on is deriving 1c, and the derivative of 1c is 1. So I'm done, because this times 1 is itself. The next one is 2 natural log c. It contains a c. That's what I'm deriving with respect to. So I am going to write down the 2, and now I'm just focused on deriving natural log c. And the derivative of the natural log of blah is, put the blah in the bottom, take the derivative of the blah and put it in the top. My next term has a c also, and so I am going to drop and flop, and that would become 9c squared. And the derivative of 6 is a constant, that just goes away. So this is my first partial with respect to c. These can look rather intimidating and daunting at first, but after you do 3 or 4 of them, you really fall back into the groove of derivatives, and they're not that hard. So here's our next problem, g of r and t. So I'm going to want to find g of r and g of t. So first of all, my first term, does it have an r? Yes, so it's going to get derived. The r portion is going to get derived, so everything else just comes along for the ride. So the derivative of the natural log of r is 1 over r. The t is a coefficient, so I could derive this like that. The next one, I'm deriving with respect to r. So r has an exponent of +1, and the derivative of a term or a variable with an exponent of +1 is just the coefficient of the variable. So this guy's derivative is 12t to the 7th. Another way of thinking about that is, like we did in the earlier example, you can walk up to this term, say I'm deriving with respect to r, so I'm going to copy down all the parts of that term that aren't r, which is 12t to the 7th, and then I'll multiply it by the derivative of 1r, and the derivative of 1r is 1. So I'm done. This next term has 4 times 8 to the r, which is a number raised to the variable. So when we derive that, the first part says we recopy it as is, 4, 8 to the r, and then we multiply it by the natural log of that base number. And then my last value is t times r, and I am deriving the r, so I can write down all the non-r parts, which is just t. Now I think about deriving the r, the derivative of 1r is 1. So the derivative of 3r is 3, the derivative of tr is t. Now I come back and it's time to do g of t. First term has a t, write down all the parts that aren't t, and now derive t to the 1. The derivative of 1t to the 1 is 1. So that's the derivative of this term with respect to t. Over here, again, it has a t. I'll write down all the parts that aren't t. And now I can derive the t portion, which is 7t to the 6th. Next guy, -4 times 8 to the r. No t, no play, go away. The whole thing is a constant and it disappears. And my final term, minus tr, well, I'm going to derive with respect to t. So I hold off on u. I write down the parts that aren't t. And then the derivative of 1t is 1. So I'm done right there. I will do another video where I just fly through some of these that are pretty tricky. So you need to practice those until you get really comfortable with derivatives. Again, it will come back and then you'll be fine. You'll just be off to the races. Happy mathing!